So in order for a matrix to be in reduced row echelon form, it has to satisfy these four conditions. If there are any rows of all zeros, they have to be at the bottom. The first non-zero entry of each row has to be a 1. That leading one of each row must be to the right of the leading ones in the rows above, so they have to go further over to the right as you go down from row to row. And all entries above and below the leading ones in the same column has to be a 0. So let's look at some examples of matrices and decide whether or not they meet all those conditions. So what about this one? Well, right away, this first row starts with a 4, so it's not in reduced row echelon form. It doesn't have a leading 1. It breaks the second rule. Okay, what about this matrix here? Let's check the conditions. If there are any rows of all zeros, they have to be at the bottom. Well, there aren't, so we don't have to worry about that. Second condition, the first thing in each row that isn't a 0 has to be a 1. Check. That condition is met. Those leading ones have to be further over to the right as we go down from row to row. Check. The leading one here is further to the right than the leading one of the first row, and the leading one of the third row is further over to the right than the leading one of the second row. Condition 3. That was what we just checked, and now condition 4, all entries above and below the leading ones in the same column have to be zeros. That checks out. So yes, this is in reduced row echelon form. What about this example? If there is a row of all zeros, it has to be at the bottom. Well, yep, there's a row of all zeros, and it is at the bottom. The first non-zero entry in each row has to be a 1. Check. Those leading ones get further over to the right as we go down. Check. And then everything above and below those leading ones has to be a 0. Check. So this is in reduced row echelon form. What about this one? Okay, if there is a row of all zeros, it has to be at the bottom. Well, there isn't a row of all zeros, so we don't have to worry about that. The first non-zero entry in each row has to be a 1. Well, oh, there's a problem. That second row doesn't have a leading 1. It has a leading 5. The first thing that isn't a 0 is a 5, so that is not in reduced row echelon form. Okay, and what about this one? If there's a row of all zeros, it has to be at the bottom. Check. First thing that isn't a 0 has to be a 1. Check. Those leading ones get further over to the right as we go down. Check. And everything above or below one of those leading ones in the same column has to be a 0. Check. So all four conditions check out, and this is in reduced row echelon form. Now the idea is, if a matrix is in reduced row echelon form, it's basically as simple as we can get it. But if it's not in reduced row echelon form, there's something we can do to the matrix to get it simpler, to get it into reduced row echelon form without changing what the solution to the system that the matrix represents is. So if a matrix is not in reduced row echelon form yet, we want to get it into reduced row echelon form by performing one or more of the following row operations. So these are the row operations that we can perform on a matrix. It's like these are the legal moves in the game, and the object of the game is to transform our matrix into reduced row echelon form. That's the object of the game, and these are the legal moves. These are what we are allowed to do to try to get our matrix into reduced row echelon form. We can interchange any two rows. We can multiply or divide any row by a non-zero constant. and we can add a constant multiple of one row to another row. And if these sound familiar, it's because they're basically the same as, remember earlier when I mentioned the things that you can do to the equations in a system that won't change the solution? You can write the same equations but in a different order. You can multiply both sides of an equation by a constant, and you can add a multiple of one equation to another equation. Well, these row operations are basically those same things, but expressed in terms of rows of a matrix instead of equations in a system of equations. So interchanging two rows of a matrix is really the same as interchanging two equations in a system of equations. Multiplying through all the numbers in a row of a matrix is essentially the same as multiplying everything on both sides of an equation by the same number. And since we can multiply by something like 1/2 or 1/3, that means we can divide through by 2 or 3 or whatever. And adding a multiple of one equation to another equation would be essentially the same thing as adding a multiple of one row to another row. So those are the legal moves. Now here is the strategy. If you were doing this yourself, as opposed to just asking the calculator to take care of all the dirty work for you and giving you the final result. But if you were doing this yourself, here's the strategy that you could follow to transform whatever matrix you start with to the reduced row echelon form that you're trying to end up with. Here's the strategy. Work on one column at a time from left to right. As you're working on a column, first focus on getting the 1 in the proper place, either by interchanging one row with one of the rows below it, or by dividing through by what's there instead of a 1. Then get zeros everywhere else in that column by adding a multiple of the row with the 1 in it to the row where you want the 0. So I am going to work through at least one example of doing this by hand, where you do all the row operations yourself to try and wrestle your matrix into that reduced row echelon form. So one way of solving these kinds of problems is to do this all yourself, the way I'm going to do in this example. But you can also have a graphing calculator or a computer app or something like that do all of that for you. You can just ask it, hey, calculator, or hey, computer, what is the reduced row echelon form of this particular matrix? And it will tell you. So you don't really have to learn how to do all of this yourself, but I like to show you how to do it yourself so that you know what's going on. So if you just have the calculator do it for you, you'll know what it is the calculator is doing and what's going on behind the scenes. Okay, so with that in mind, with that disclaimer that you don't have to do it this way, let me show you how to do it this way if you want to. So you do have to know how to take your system of equations and write the augmented matrix. And we've already talked about how to do that. You just take the numbers involved and put them in a matrix. So this example we're going to be working through. The equations are 2x plus 2y plus z equals 4, 3x plus y minus 2z equals 5, and x minus 3z equals -2. So for each one of those equations, we're going to take the numbers involved and put them into the matrix. The first equation, the numbers are 2, 2, 1, and 4. Hopefully you see where those came from. What about the second equation? What are the numbers that I'm going to put into the second row of the matrix? They are 3, 1, -2, because it's minus 2z. The coefficient on z is -2, so that goes in here, and 5. And what about the bottom row? What do you think the bottom row of the matrix is going to look like when I take the equation x minus 3z equals -2 and put all the numbers in place? So the first column is the coefficient on the x, that's 1. The second column is for the coefficient on the y term, and that would be 0. And the third column is for the coefficient on the z term, and that would be -3. And then over in the last column, we have the constant term, and that is -2. So there's our augmented matrix: 2, 2, 1, 4, 3, 1, -2, 5, 1, 0, -3, -2. Now, before we work this out ourselves, let me show you how you would put this into a graphing calculator if you wanted to do it that way. So you would go to the matrix menu by pushing second and then the button that says matrix above it. Or some calculators just have matrix on one of the buttons. So you get to the matrix menu that looks like this. You're allowed to have several different matrices, but we only need one of them. So we'll just work with matrix A. Use the arrow button to edit, move over to edit, and then hit enter to edit matrix A. This particular matrix is a 3 by 4 matrix. It's got 3 rows and 4 columns. So put in 3, enter, 4, enter, and now the calculator is set up to let me put in a 3 by 4 matrix with 3 rows and 4 columns. So now I'm just going to type in the numbers: 2, enter, 2, enter, 1, enter, 4, enter, 3, enter, 1, enter, -2, enter, 5, enter, 1, enter, 0, enter, -3, enter, -2, enter. And now this next step is important. We got to quit out of this screen. So hit second and then the button that says quit above it. If you want to see the matrix that we just typed in, go back to the matrix menu. And while you're here on names, just hit enter and enter again. And right there is the matrix that we just put in as matrix A. You don't have to do that, but if you want to make sure it looks like what we want it to look like, that will show you the matrix that's put in for A. What we really want is the reduced row echelon form of that matrix. Here's how to get the calculator to give you that. Go back to the matrix menu. Move over to Math, and now arrow down to RREF. Now be careful, there's an REF. That's not what we want. We want RREF for reduced row echelon form. So select that, and I need to tell the calculator that I want the reduced row echelon form of matrix A. So go back to the matrix menu again, and this time just select matrix A, and now hit enter. And what it's showing me now is the reduced row echelon form of matrix A. 1, 0, 0, 4, 0, 1, 0, -3, 0, 0, 1, 2. And looking ahead, that's going to mean that the solution to the system is for 1 times x plus 0 times y plus 0 times z to equal 4. In other words, x equals 4. And then y has to equal -3 and z equals 2. So the solution to that system turns out to be x equals 4, y equals -3, and z equals 2. I'm going to end this video here because we do have our solution to the system, but I'm going to come back in the next video and work through how you would figure that out yourself if you didn't have the calculator to tell you how you'd go through the steps of getting that reduced row echelon form.